Hi everyone, let's go ahead and get started with the review. Now these problems are not the exact same ones as the review, but they are ones that are similar. So they do have they have the same idea of what you're doing. So you should be able to watch this, pause it, and then go complete that example. All right, for number 5, we are going to identify which operation is happening, and then we are going to complete that operation. So not number 5, number 1. So number 1, I have two binomials here, and with these two binomials, I am adding them. Okay, so all that means is that I am adding the like terms. So I'm going to do 5 plus 2, and then I am going to do 3i plus 1i. So 5 plus 2, that gives me 7. And 3i plus 1i gives me positive 4i. I cannot combine those because they are, one is a real number, the second one is an imaginary number, so these are complex. So my final answer is 7 plus 4i. All right, number 2, on this one, the operation is subtraction. So I am going to take 8 minus negative 14. Now 8 minus 14, the double negative makes it a positive, so that gives me 22. Then I have 5i minus negative 3i. So again, that double negative gives me a positive, so that's positive 8i. So 22 plus 8i, they cannot be combined. So that gives me my complex simplified answer there. Okay. All right, on number 3, these ones, the operation in the middle is multiplication. So when it's multiplication, this is when we're going to use distribution. So 10 times 6, 10 times 3i, negative 4 times 6, or negative 4i times 6, and negative 4i times 3i. So 10 times 6 gives me 60. 10 times 3i gives me positive 30i. Negative 4i times 6 gives me negative 24i. And negative 4i times positive 3i gives me negative 12i squared. I times I, this is when it makes I squared. Okay. Now this I squared here, I am going to cancel out and replace it with a negative 1. Now, I'm not going to take any chances getting this wrong, so I'm going to go ahead and rewrite it. So I have 60 plus 30i minus 24i. Negative 12 times negative 1 gives me positive 12. Now I'll go ahead and combine like terms. Okay, like terms are our real parts first. So 60 plus 12, that gives me 72. Then I will combine my imaginary parts here, which is 30i minus 24i, and that gives me positive 8i. 72 and 8i, they are not the same because one's real, one's imaginary. So there's my answer. Okay. All right, now let's go over to number 4. Number 4, this one has an I in the denominator. I cannot have an I in the denominator, so I need to remember that I need to multiply it by its conjugate. And you know what? I'm going to show you something here that I made a mistake on. This should not be here. Originally, when we first start this, these parentheses will not be there. Okay. So what I need to do is understand that I cannot have an I in the denominator. So to get rid of that I have to multiply by the conjugate of the denominator. The conjugate is the same terms, but instead of adding them, now we are subtracting them. So I will have 2 minus 5i. Of course, now I put those parentheses there. I'm just saying originally they would not be there. Whatever I do to the denominator, I have to do to the numerator. Okay? All right, again, look at the operation happening between the two factors. So right here, they are being multiplied. Right here, they're being multiplied. So if they're being multiplied, that's when I can use distribution, okay? So I have 7 times 2. That gives me 14. 7 times negative 5i gives me negative 35i. And the denominator, I have 2 times 2. And that gives me 4. 2 times negative 5i gives me negative 10i. 5i times 2 gives me positive 10i. And 5i times negative 5i gives me negative 25i squared. Again, I squared will be replaced with a negative 1. Also, by looking at this, I can see that negative 10i and positive 10i, they cancel out because it's a conjugate. Okay? So when I rewrite this, I have 14 minus 35i divided by 4. And now this is a positive 25 because negative 25 times negative 1 gives me positive 25. So I've got 14 minus 35i divided by 29. Okay. So my solution, 14 minus 35i divided by 29. Now what was the reason for that? Is because we cannot have an I in the denominator, and in the very beginning, I did have this I right here. Okay? All right, so that is one working with conjugates. Let's go ahead and go down to number 5. Number 5, we are solving by taking the square root. Guys, it's really important that every time you remember when you're taking the square root, you have to put the plus or minus in front of it. I cannot say that enough, but I still have a lot of people not putting the plus or minus in front of it, okay? So first thing though, we've got to isolate the x. So in order to get to the x value, I'm going to pick a different color. In order to get to the x, it's attached to x squared, which is attached to 3x squared, which is attached to negative 75. Okay, so we've got to get rid of that negative 75 first. If that doesn't help you, just think about doing PEMDAS backwards. Okay, so first thing I'm going to do is add 75 to both sides. So I will have 3x squared is equal to positive 75. Now I'm going to divide both sides by 3. So I get x squared equals 25. Next step, take the square root of both sides. Don't forget the plus or minus. I know I say it, and yet people will still forget it. So the square and the square root cancel out. So I am left with x equals plus or minus the square root of 25 is 5. And those are my solutions. So x equals 5 and x equals negative 5. Can you leave it just like this? Yes, as long as you understand that that is 2 solutions. Okay? All right, for problem number 6, same thing, solving by square roots. First thing though is that it needs to, I'm trying to get the x squared by itself, so I need to isolate the x squared. So I'm going to add 35 to both sides. So I have 7x squared minus 35 is equal to 14. When I add 35 to both sides, I get 7x squared is equal to 49. Divide both sides by 7. I get x squared is equal to 7. take the square root of both sides. And I get x is equal to plus or minus, and I cannot take the square root of 7. So x equals plus or minus radical 7. Okay? All right, next one, completing the square. Most people today had trouble on this one, okay? So this is one of the ones that you put a question mark by, then this should be one of the problems you leave until the end. You should be doing the stuff you know first, then the stuff that takes work, then coming back to the stuff that gives you the most trouble, okay? Whenever we're completing the square, we are going to start with b divided by 2 squared. We need to know what that value is because that's what makes it a perfect square trinomial. So b divided by 2, so I have 8 divided by 2 squared. That gives me 16. Is our C term 16? Nope, it's negative 20. So I need to move that negative 20 out of the way so that I can put 16 there. So I have x squared plus 8x plus a blank space equals, moving the negative 20 to the other side makes it a positive 20 plus a blank space. Now in that blank space, that's where we're going to put this number. So I've got 16 here and 16 here. Okay. When we're completing the square, we are looking at the left side of the equation. Okay. I am trying to factor this. If you cannot remember how to factor the way we talked about with completing the square, you can always go back to using our diamond method. 16 goes on top, 8 goes on the bottom. What two numbers multiply to 16 that add to 8? So that would be 4 and 4. So that means our factors are x plus 4 and x plus 4. Now remember, these factors are identical. So since they're identical, when I write them, I write it as x minus 4 squared because we have 2 copies of that. For those of you guys that are working with the shortcut, x squared, okay, we take the square root of that for x, and then we take half of b, that gives us the negative 4. Okay, so if you're somebody who remembers the shortcut, that's what we're working with. If you don't remember the shortcut, then you'll need to factor it like this. Okay, so we have x minus 4 squared is equal to 36. Now, to get rid of the square, I take the square root of the left side, square root of the right side, include the plus or minus. So then I have x minus 4 is equal to plus or minus 6. To isolate x, I move the negative 4 over to the opposite side of the equation. I have x equals 4 plus or minus 6. So 4 plus 6 gives me 10, and 4 minus 6 gives me negative 2. Those are my solutions. All right, last one, quadratic formula. Now, on the quadratic formula, okay, we have all of this. The only piece that I'm worried about at first is the discriminant, the stuff underneath the radical, okay? So taking b squared minus 4ac. Our b value is negative 6. A value is 2, and our C value is 8. Negative 6 squared gives me 36. Negative 4 times 2 is negative 8. Negative 8 times 8 gives me negative 64. Then when I've got 36 minus 64, that gives me negative 28. That's my discriminant. A negative number means 2 imaginary solutions. So I have x equals negative b plus or minus the square root over 2 times a. So negative 6, negative 28, and 2. So x equals positive 6 plus or minus I. I cannot take the square root of 28, but I do know that it's radical 4, radical 7 are equivalent all over 4. So to simplify that even further, x equals 6 plus or minus 2i, because the square root of 4 is 2, radical 7 all over 4. X equals 6 plus or minus 2i radical 7 divided by 4. All right, if you have any questions, go ahead and message me. Otherwise, make sure that you are studying for the test, and I look forward to seeing you all tomorrow.